Hi, I'm Larry Puckett, the DCC guy. Well, as you might have noticed from the opening, we managed to go over 20,000 subscribers for this channel as of Sunday, September the 19th. So I want to welcome all of you new subscribers to the channel. You know, we went over, I think we had more than 500 new subscribers in the last week and over 1,000 in the last month. So I really appreciate all of you, and I want to welcome you new guys to the channel and hope that you will enjoy the videos that we have here. You know, there's over 200 videos here available for you to go back and look at. So don't feel like you have to wait for a new video every week, because there are just tons of them available on the channel homepage for you to go look at and view. Now, at the end of the last video, I mentioned that this week I was going to do a series of a couple of videos anyway on signals. And I had hoped to start that on Monday, but some other things got in the way. So we're going to do a Monday-Friday combination here. So what I want to do today is we're going to take a quick look at signals in general, the type of signals used in North America, because, you know, I know a little bit, a tiny little bit about UK signals and not much more than that. So I'm not going to venture down that track and get myself in trouble. But what I will do is go over the small amount that I do know about North American signals, what we have used here in the US since probably around the turn of the last century, the beginning of the last century. And then after that, I'm going to show you a set of signals that I use here on the Piedmont Southern. We will take a look at the way that I implemented some signals to protect a bridge crossing. And then we're going to go ahead and I will take you over to the layout, show you that bridge crossing, show you the signals, and then we'll run through a scenario with two trains converging on that one bridge at the same time, and I'll show you how the signals work in order to protect that crossing. So let's go ahead and get started with the video. So let's go ahead and get started with today's discussion of signals. Now, I'm going to talk a little bit about signals up front. So for those of you who don't want to hear about signals or know everything you need to know about signals already, why don't you take a look up down below me here, and I'm going to put a message down there with a timestamp. And that's the point where you can jump past the signals. So all you have to do is hit that little scroll button along the bottom of the screen, move forward to that point in the timeline, and you'll skip everything I'm going to say about signals. And, you know, at some point you might decide to come back and actually watch it. So what do I have to say about signals? Well, first I'll tell you, I am far from an expert on signals. There are a lot of different kinds of signals, and different railroads have different signaling practices all across the United States and around the world. And that's one thing I do want to point out, you know, that in countries around the world that were heavily influenced by the United States, then their railroads very often follow American practices. In countries around the world that were once part of the UK, the Commonwealth nations for a large part, follow generally the UK British type signaling practices. Now that is a very broad statement to make, and individuals will vary considerably, I'm sure. I'm going to just cover what I know about the North American or US practices. Now, there's two basic types of signals that have been used over the last, 70 years or so here in the United States. One is ABS, or automatic block system, or automatic block signals. And then there is CTC, which is centralized traffic control. Now, the ABS system uses detection systems that are built into the tracks. It allows and allowed the railroads to be able to set up signals that would prevent trains from entering occupied blocks. And that was a long-standing problem with accidents, because trains sometimes would get into the same block and run into one another. And, it didn't sit well with the customers or the stockholders or the company president, particularly since one of them on the Southern Railway got killed that way. What we have with ABS is a system where you have the signals located at each end of an active block, which is a section of track, and some way of detecting whether there is a train operating within that block of track. And if there is, you'll get a red light. Now, the way that most of these are set up is that if the block immediately ahead of you has a train in it, you'll get a red light. If that block is empty, but the following block is occupied, you'll get a yellow signal telling you to slow down, be aware that there is another one operating ahead of you. You might have to stop at the next set of signals. And that's the type of system that I use here on the Piedmont Southern. It's the easiest to set up and operate as far as I'm concerned, and it's what the prototype, the Southern Railway, was using up until about 1965. And in 1965, they went to CTC. Now, with a CTC system, you typically would have a dispatcher or someone, an operator, at a centralized location with a control board and a way of actually throwing the switches or turnouts on the main line or on the line, and also a way of changing the colors of the signals. I'm sure you've seen pictures of agents or operators or dispatchers, whatever, sitting at these big desk-like features, big green panels with all kinds of switches on them and a track plan. And that's what a CTC operation generally is based on. And it allows one individual to control the operation of all the trains within the section that he has control over. Now, one important thing to realize about this is if you decide to go with signaling, you need to take a look at what your prototype railroad that you're either following or freelancing based on, and learn something about their signaling practices, because it adds a little bit more interest and realism to your model railroad if you're following actual practices that were used on that prototype that you're modeling. But you don't have to. I mean, you could use ABS, you could use CTC, whatever. And these things have gotten much, much easier to implement in the last decade or so, largely because of the advent of computers and a lot of the integrated circuitry that's available to us as modelers. And I will be showing you one type of signaling system that I use here on the Piedmont Southern. And actually, I showed you another one recently, and that is the dwarf or ground signals available from DCC Concepts. And those are a type of signaling system that is used in yards and in certain limited areas to show you routes and turnout indications, whether or not a turnout is thrown for a certain route or not. And so they're a specialized part of the signaling system. What I'm going to show you today, though, is also a specialized approach. And let me tell you why. What I'm going to show you in a minute here is the implementation here on the Piedmont Southern of what's called a Ganttlet Track. And basically, a Ganttlet Track allows a railroad to run two tracks through a very narrow space so that essentially those two sets of tracks are occupying the same space at the same time. And where would you do that? Well, you might have a single bridge that you want to run two tracks across, and this saves you building another bridge. You might have a single bore tunnel where you need to run two sets of tracks through. So this allows you to combine them or run them close together so that they can actually both go through there. In towns and cities, there might be areas between buildings and streets where there isn't adequate room for two fully separated sets of tracks. And in those cases, they bring them together and run them through a gantlet. You'll see it referred to as gantlet and gauntlet. I've seen it both ways. John Armstrong in his book referred to it as Ganttlet Tracks, and Model Railroader in the articles that I did spelled it gantlet. I've also seen it spelled gauntlet. So there's two separate ways of talking about this, and if you look up Ganttlet and Gauntlet Track on the internet, you'll see both used. Okay, let's go on past that, because that's all I want to say. What I'm going to show you here, though, is a different type of photo detection in use. And in most cases on model railroads for block detection, we use what's called a current sensing circuit so that it can actually sense the electricity flowing through the rails and through the motor and lights and things of this nature within a block, and sense that and trip a circuit and control the signal lights based on that. The circuit that I'm going to show you today, though, is based on optical detection. And it uses a phototransistor placed between the rails and between the ties in order to be able to detect when a locomotive or a string of cars is over it and blocking light from above. The reason I went about doing it this way was I'm already installing block occupancy detectors on the layout, and I wanted some way to have a second optical detection system installed within that block. So it's sort of like a block within a block. And the easiest way to do that was come up with something that would be electronically separate from the block detection that is based on current that is used in the block itself. And optical detection is one way to do that. And I wrote about the Ganttlet tracks back in the September and October issues of Model Railroader in 2014. And then I wrote another article in May of 2015 that showed a circuit that I was using in order to be able to control those signals using optical detection. And this is that circuit. So you can see it's a little bit big and kludgy. I only needed to do a couple of these, so I soldered these up by hand instead of using a circuit board that you have to make or order. And this one is fairly straightforward. One of the problems with this circuit was it requires a lot of light over it. You can use infrared LEDs located directly above the photo transistor, and that can be very effective in low light settings. But I didn't want to do that because it was in an open area and it wasn't a good place to hide an infrared LED. So I went with this. What I have subsequently found is a different circuit, and it's one that uses what's called a comparator. And a comparator is an integrated circuit, and it compares the voltage from the phototransistor when it is in the light and when it is in the dark. And it is much, much less sensitive to light levels. So it will work in much, much lower light. I used a similar circuit for the crossing gates in Charlottesville that I installed as one of the chapters in my book, Wiring Projects for Your Model Railroad. And when I installed that, I had a hard time getting it to work right. And I kept trying to do all kinds of things to increase the amount of light and to change detection methods and all of this. I even rigged up some infrared LEDs to kind of boost the light, and nothing worked. Well, finally, I cut down on the light, and darn if the darn thing didn't work better and very reliably with lower light that I was actually giving it too much light for it to work properly. So what I'm going to be doing today is show you the installation on the model railroad on the Piedmont Southern, where I've got this Ganttlet bridge set up, and I'll show you how the circuit works there to control trains going north and south across a single track bridge. Well, actually, it's not a single track bridge because it's got two tracks running on it, but it's only a single track wide. So let's go ahead and move on over to the Piedmont Southern, to the layout, and take a look at how that works. Okay, here we are at the crossing of the Rockfish River, located between Charlottesville and Lynchburg. And in this location, there were originally two bridges, two parallel bridges just like this. But when the railroad went to CTC operations, they removed a lot of these double bridges that they had, and because they were able to control the trains so much more efficiently that they could actually just alternate sections of single track with double track on the main line. And so they were taking these bridges out. Now, in my time period, 1957, they were still using automated block signaling or control. They did not have CTC at this time. So what I've done here is gone ahead, pulled the bridge out to make things a little more interesting, and put in this Ganttlet Track. So if you're looking at this bridge, and let me just tip the camera forward so you can see it, you can see here that there are 4 sets of rails on this bridge. And that allows 2 trains, trains going in opposite directions, to use this single bridge. And I thought this would make an interesting design element here on the model railroad. It never existed on the prototype, but you know, rule number 1, it's my railroad. So this is what I've done. Now, if you look back here, there's 2 separate tracks coming down the main line, and then they get to this point where there's only 1 bridge, where the other span was taken out. And you can see right there coming across that dirt road, there is a section of track on a diagonal. That's where the 2 separate tracks are coming together to form this Ganttlet Track. And the way I built this, and I explained this in the September and October issues of Model Railroader in 2014. So it was a 2-part article on building the bridge crossing and the Ganttlet Track arrangement. So what we have here then is it allows the trains coming from opposite directions to come across this section here, join together on the bridge, and it allows 2 separate tracks then to use the same space. Now, the way that you build this, if you look real close, you can see here, this is an old, I think a number 8 turnout, and I just took the point section off and used the frog section to to combine the 2 tracks, as you can see here. And I explained this in detail in the article on how I went about building this. The real problem, of course, with this type of arrangement is, since you've got 2 sets of tracks here on this bridge, it allows potentially 2 trains to try to occupy this bridge at the same time. So what I had to do then was come up with a way to regulate the flow of trains across this short section. And I could have done it with standard block occupancy detectors, but I've got this whole block detected, and so I wanted to be able to detect within a block. And the easiest way to do that was to come up with an optical sensing system that would just control this one short section of track, and I could install a pair of signals to prevent the 2 trains from entering the same section of track at the same time. And that's what I did. And I explained how to build the occupancy detection circuit in the May 2015 issue of Model Railroader magazine. So, and let me show you, I'll pull the camera back up here, and we'll take a look here at the entrance to this section. Okay, so you can see here we have a train that is just coming north. He right now has a green light, but in just a second that's going to turn red because we have a train approaching from the north as well. So they're converging on the bridge. We've got to have some way to stop this guy from crossing. Right here, there is a phototransistor placed between the rails, between these 2 ties. So when this locomotive comes down and covers that photodetector, that phototransistor, it's going to put it in the dark, and that's what's going to trigger the circuit. So let's bring it on through. Okay, so he's just crossed over there. The signal light down on the south side of the bridge just went red, as you can see now. And the locomotive from the north is approaching across the bridge, and he's going to start diverging. And the tail end of the train will uncover that photodetector, and things will start to happen. So it's uncovered it now, and we're doing about a 15-20 second countdown before this goes green. So if you watch close, we're clearing the signal now, and you can see we got the timing down real close there. Now he has a green light to go north across the bridge. Well, that's a wrap for today's video. I hope that I gave you a little bit of information to help you understand the difference between automated block system signaling and centralized traffic control signaling. These are the predominant systems that have been used here in North America since the beginning of the 20th century, roughly. I think CTC came in the earliest applications in the 1920s, and the ABS system has been used earlier than that, all the way up to the present on some railroads. So come on back on Monday and we'll take a look at the specific circuit that I used to implement the photo detection control system here on the Piedmont Southern that I've just shown you. Then I'll take a look at the actual circuit board, go over the various components with you and show you how it's hooked up, and that'll be a wrap for this particular look at signals. Further down the road, we will take a look at the ABS type logic system circuit board that I am using here on the Piedmont Southern to implement the other types of block signals. In the meantime, have a great weekend, and we'll see you here on Monday for another video from the DCC Guide. Bye now.